In this video, we'll look at the speed of adoption of technology in markets with network externalities. In markets with network externalities, a new technology could be adopted too quickly or too slowly. Excess inertia is where a new technology is not adopted even though adoption of this technology would make consumers better off. Excess momentum is the opposite. A new technology is adopted even though overall consumers would be better off if it were not. Now, the idea of excess inertia is that everyone adopts a wait and see approach. Nobody buys the new technology because they think nobody is going to buy, or they wait until they see other people buy. To see why excess inertia might occur, let's look at a simultaneous move technology adoption game. This game is very similar to the coordination game in section 5.1. We have two players who simultaneously choose old or new, so they're choosing between an old version of a technology or a new version of a technology, and the cost of switching from the old to the new technology is CI. There are network externalities here, so if both of the players have the same technology, then they get a benefit. The benefit is OI if they both have the old technology, and the benefit is NI if they both have the new technology. If they choose different technologies, then they get no benefit from those technologies. So this game is described in the payoff matrix. O is the old technology, N the new technology. So let's look for the Nash equilibria of this game. Before we do so, what are the assumptions we're going to make about the value of OI and NI and CI? Well, we're going to assume that the old technology gives a non-negative benefit, and that the benefit of the new technology is more than the cost. So let's look for the Nash equilibria. Let's look at player 1. Should they choose the old or the new technology if player 2 chooses the old technology? Well, since if player 1 adopts the new technology, they only incur a cost of C1 and get no benefit, it's better to choose to stay with the old technology. O1 is more than minus C1. Similarly, player 2 will choose to adopt the old technology if player 1 adopts the old technology. O2 is more than minus C2. What would player 1 do if player 2 chose the new technology? Well, if player 2 chose the new technology, then player 1 would also choose the new technology because the benefit of the new technology to player 1 is more than the cost as long as player 2 chooses to adopt as well. Similarly, player 2 would choose to adopt the new technology if player 1 did. So in this game, the players will just do what the other player does. We have two Nash equilibria, one where they stick with the old technology and one where they adopt the new technology. So we have multiple equilibria in this game. Is one better than the other? Well, that depends on how big the benefits are of the new technology relative to the old technology. If the net benefit of the new technology is more than for the old technology, then the equilibrium where both players adopt the new technology, Pareto dominates the equilibrium where they both stick with the old technology. So we have the situation where there are two Nash equilibria and one of them is better than the other. So to explain why there might be excess inertia, we have to think about why might it be more likely for the players to stick with the old technology rather than adopt the new technology, which would lead to the higher payoffs. So to think about why there might be excess inertia and why players might be more likely to choose to stick with the old technology, let's again look at this game, but assume that the payoffs are such that NI equals 2CI. So the benefit from the new technology is twice the cost. And let's also assume that the cost is very large. Now the game will still have the same equilibria, but let's think about which one is more likely. So let's consider player 1. If they choose N, then their possible payoffs are minus C1 and C1. And player 1 maybe isn't sure what player 2 is going to do, and perhaps they even think that player 2 is not rational, or they could be a Luddite who's never going to adopt the new technology. So player 1 is facing a lottery when they choose to adopt the new technology, and this lottery yields either minus C1 or C1. And so for each player, adopting the new technology is a lottery, yielding minus CI or CI. So either a large negative or a large positive payoff. Now let's think about what happens if player 1 chooses to stick with the old technology. Then they get either O1 or 0. So sticking with the old technology guarantees a minimum payoff of 0. So if player 1 is choosing between adopting the new technology and possibly getting a large negative payoff, or sticking with the old technology and guaranteeing themselves a minimum payoff of 0, it might be that they choose to stick with the old technology. So it seems that perhaps the equilibrium where they both stick with the old technology is more likely. So although the new technology is better, you choose to stick with the old technology because you're worried that the new technology is not going to be adopted. So in this simple model, the existence of network externalities may imply excess inertia. That is, it might imply that the new technology is not adopted at all. In a more complicated model, we could introduce multiple periods. So if we had a model with 2 periods and there was uncertainty over whether other consumers would adopt, so some of the consumers might be Luddites, then consumers may adopt the wait and see approach, and they may choose to adopt in the second period or not at all, rather than adopting in the first period. In this model, everyone waits to see if other people buy, so this is excess inertia. On the other hand, we may have excess momentum where a technology is adopted, even though overall consumers would be better off if it were not adopted. The reason a technology might be adopted, even though consumers are better off if it weren't, is that if there are enough early adopters, they essentially force their choice on the others. The others are better off switching from the old to the new technology if there are enough people adopting that new technology because of the network benefits. So to illustrate this idea, we're going to now look at a sequential move technology adoption game. The payoffs are exactly the same as in the simultaneous move game we looked at. It's just that player 1 chooses to stick with the old technology or not before player 2, and player 2 observes player 1's choice before making their own choice. So we have the game tree here. Player 1 is at the first decision node, and then player 2 has their 2 decision nodes after observing player 1's choice and makes a similar choice, old or new. And the payoffs in the green boxes are just the same as the ones in the payoff matrix from before. So let's solve this game. So we're looking for a subgame perfect Nash equilibrium, which means we're using backwards induction. We start from player 2's choices, work out what their optimal choices are, and then look at player 1's optimal choices given player 2's optimal choices. So let's look at player 2's optimal choice given that player 1 has chosen to stick with the old technology. So we're looking at the left part of the game tree, and we're looking at the second row of the payoffs. Player 2 is choosing between a payoff of O2 or minus C2, and as before, we're going to assume that O2 is non-negative, so player 2 would choose to stick with the old technology. Now what if player 1 chooses to adopt the new technology? What should player 2 do? So now we're looking at the right hand side of the game tree and again the second row. Player 2 will choose to adopt the new technology so long as N2 minus C2 is positive, and this is something we're going to assume. So player 2 prefers to adopt the new technology if player 1 adopts the new technology. So now that we've found player 2's optimal choices, we need to look at the choice of player 1. So will they choose to stick with the old technology or adopt the new technology? Well, they're comparing the payoffs O1 and N1 minus C1. And we're going to assume that player 1 prefers the new technology to the old one. And so player 1 will choose to adopt the new technology. So because player 2 will always do what player 1 does, player 1 can then essentially choose the outcome of the game, whether the new technology is adopted or not. And here they choose the new technology because they prefer it to the old. So the equilibrium outcome is that the new technology is adopted by both players, and their payoffs are here. So let's think about whether this is the right outcome. Is the equilibrium outcome better than the situation where they stick with the old technology? So let's compare the total payoffs in the equilibrium to the payoffs when they stay with the old technology. So in the equilibrium, the total payoffs are N1 minus C1. Those are the payoffs of player 1, plus N2 minus C2, payoffs of player 2. And what are we assuming about these payoffs? Well, we have some assumptions listed above. We are going to assume that player 1, although they prefer the new technology to the old, they only just prefer it. So N1 minus C1 is approximately equal to O1, but larger than it. So this quantity here is approximately 0.1. What about player 2? We assume that they prefer to adopt the new technology if the other player adopted the new technology. So N2 minus C2 is positive, but it's approximately equal to 0. And this also means they prefer the old technology to the new. Now let's look at the total payoffs. They are approximately 0.1 plus 0. Whereas if both the players stick with the old technology, then total payoffs are 0.1 plus 0.2. So in the equilibrium, the payoffs of player 1 are approximately the same as when they don't switch, but player 2 is getting a lower payoff than when they stick with the old technology. So in the equilibrium, the lead adopter, because they slightly prefer the new technology to the old, they adopt the new technology, but this imposes a large loss on the second adopter. So the lead adopter slightly prefers the new technology, the second adopter greatly prefers the old technology, and so we end up with a situation where the total payoffs are lower in the equilibrium where the technology is adopted than when they stuck with the old technology. And this is because of these network externalities, which mean that the second adopter will follow the first adopter. So the first adopter has forced their choice on the second adopter for a small benefit to themselves, but a large cost to the second adopter. So this is excess momentum. The technology is adopted even though overall payoffs are higher when it's not adopted. So network effects may lead to excess inertia or excess momentum in technology adoption.